Have you ever pondered over how fire tank sizes are calculated? It's not just a random guess, but rather a precise science that involves several critical parameters. Today, we're diving into the nitty-gritty of fire tank size calculation, demystifying the process involved in ensuring our safety. Imagine a scenario where a fire has broken out. The first line of defense is the fire sprinkler system, which is fed by a fire tank. But how do we determine what size that fire tank should be? The answer lies in a combination of factors including the building's structure, its occupancy, and the local fire codes. Firstly, we need to consider the building's structure. This includes the building's total square footage and the materials used in its construction. For example, a steel structure might require a larger tank than a wooden one due to steel's higher heat resistance. The next factor to consider is the building's occupancy. A residential building with a few occupants would require a smaller tank compared to a commercial building that accommodates hundreds of people daily. The occupancy also determines the fire load, which is the maximum amount of heat that can be produced if all combustible materials in a space were to catch fire. Thirdly, the local fire codes come into play. These codes, which vary from place to place, prescribe the minimum tank size requirements. It's crucial to comply with these codes, not just for legal reasons, but also to ensure the safety of the building's occupants. Once we have all these parameters, we can begin with the calculation. We start by determining the duration for which the sprinkler system should operate. This duration, specified in the fire codes, is typically between 1 and 3 hours. Next, we calculate the water demand. This is done by multiplying the sprinkler system's flow rate by the duration. The flow rate, expressed in gallons per minute, is determined by the type of sprinkler heads installed and the total area they cover. The result of this multiplication gives us the preliminary tank size, but we're not done yet. We also need to consider a buffer volume. The buffer volume is an additional amount of water that's kept in the tank to compensate for any unforeseen circumstances like a delay in the arrival of the fire department. Finally, we add the buffer volume to the preliminary tank size. The result is the final fire tank size. This size ensures the sprinkler system will have enough water to operate effectively, minimizing the damage in case of a fire. In summary, calculating the fire tank size involves considering the building's structure and occupancy, following local fire codes, determining the operation duration and water demand, and finally adding a buffer volume. This process ensures the fire tank is adequately sized, providing a critical line of defense during a fire. Remember, fire safety is not just about having a fire tank, it's about having a fire tank that's correctly sized. A well-calculated fire tank size is a crucial element in fire safety, ensuring that in the event of a fire, the sprinkler system has enough water to help control the situation until the fire department arrives. So, understanding how fire tank sizes are calculated is not just interesting, it's vital for our safety.